Hello friends, welcome to this video lesson. Today we are going to discuss another important topic of your online course. The title of today's video lesson is Quartile Deviation and its Interpretation. Friends, presently we are in the 14th week or the 14th module of your online course. The title of your online course is Assessment for Learning and the code is BES 127. And before starting our discussion, let me to introduce myself. I, Dr. Niradhar, Associate Professor, School of Education, Indira Gandhi National Open University. Welcome you all to this video lesson. So friends, now go forward to know that what are the different video lessons are included in the 14th module that is included in the 14th week of your online course. As you know that presently we are discussing the module that is measures of dispersion. In 13th module already we have discussed measures of central tendency, how to calculate the central values of a distribution. It may be an average score that's called as mean, it may be median, or it may be mode. Okay, we have already discussed that in group data or in raw data or in ungrouped data, what methods and what techniques, what formulas that we have to use for calculating the measures of central tendency. And today we are going to discuss more about the statistical applications that we do for analyzing and interpreting students' performance, students' result. Okay, so that's why only measures of central tendency is not enough to interpret the score of the students, because nature of distribution or the distribution of the scores of students in a group, you will find that it varies group to group. Okay, sometimes you will find that the scores are highly skewed. Sometimes you will find that the scores are either positively skewed or negatively skewed, which is not as per the norm of normal probability curve. Okay, so that's why in such case, which statistics that we are supposed to use for better interpretation of the result of the students. So that's why another statistical application is included in this online course in assessment for learning, that is measures of dispersion. This is also called as measures of variability, means how the scores are variable, how the deviations of the individual scores are from the average score, and how we can calculate deviations of the scores or variability of the scores. Okay, in terms of, you can say it may be in terms of standard deviation, it may be in terms of quartile deviation, it may be in terms of average deviation, or the simple deviation measures that's called as, or the dispersion measure that's called as range. So how to calculate it? So our focus will be upon these important techniques and methods to measure the dispersion of the result of the students, the scores of the students. And friends, in this module, we have already discussed our first video lesson, that is percentile and percentile rank, its calculation and interpretation. What is the concept of a percentile and how to calculate percentile, at the same time, how to calculate percentile rank. Okay, and what is the importance of calculating percentile and percentile rank? We have already discussed in the earlier content point of this module. And now the second video lesson is quartile deviation and its interpretation. Just now we are going to discuss. And another two video lessons of this module, that is mean deviation and its interpretation, how to calculate mean deviation and how to interpret the result in mean deviation. Then further we will also discuss about standard deviation, that's called as ST. Standard deviation, how to calculate standard deviation and how to interpret the result of standard deviation. So friends, now let us go forward to focus upon the learning outcomes that are included in this particular video lesson, that is quartile deviation and its interpretation. As you know, certain learning outcomes that have been taken, and I am very much hopeful that after going through this video lesson, at the same time the part E content of this module relating to quartile deviation, you will be able to explain the concept of measures of dispersion, you will be able to explain the concept of quartile deviation, then you will be able to calculate the quartile deviation both in ungrouped and grouped data. Okay, so two types of data will be there. One is ungrouped data and other is grouped data. Ungrouped data is called as the data which is given in terms of you can say raw values, raw data, individual scores. And group data, when the scores are grouped, when the scores are organized in terms of class interval orders. Okay, so how to calculate quartile deviation both in ungrouped as well as grouped data, and further how to interpret the result that we got from by using the quartile deviation. That is, you will be able to interpret the result of quartile deviation. And of course, we'll also in this video we'll first start our discussion by understanding what is a range, okay, and how to calculate the range, because range is called as the very lowest level of measures of dispersion. And after range, further we can proceed to understand and calculate quartile deviation, then average deviation, then standard deviation. Now let me to give one example, then after I think this example will make you easy to understand the concept of dispersion. Here look at the data of three groups. So here n is 8. It means total 8 number of students are there in 3 different groups, in group A, group B and group C. In group A 8 students are there, in group B 8 students, and group 3 also 8 students. And here you see scores are given in group A just like 20, 22, 18, 15, 25, 20, 10 and 30. So 8 different scores are given. And in group B, again here you see this is another group, 8 students are there, and scores of 8 students in group B is also given. And accordingly in group C, scores of 8 students are also given. But coincidentally, what we find here in group A, if I will add total scores, that is it will be 160, and total number is 8 because total number of students are 8. So if I will calculate mean score or the average score, that is sum of x upon 8. 8 means here n. So that's why if I will add all these scores, it is 160 and divided by the total number of the cases, that is 8. So 160 upon 8 is equal to 20. And coincidentally, you see in this situation in group B, if I will add all these scores, it is also again 160 and total number of scores are also 8. So 160 upon 8 is again 20. And accordingly in group C also, you see the scores are different, but sum total of all these scores are also again 160. So 160 upon 8 is equal to 20. So here what I mean to say, in 3 different groups you will find that the scores are different, okay, highest score, lowest score, and different scores, you will find that this is not equal. But we are getting the total, if I will add the total score, we are getting a same value, that is 160. And total number of students in each group is 8. So that's why we are getting here a similar mean score, that is 20 in group A, 20 in group B and 20 in group C. But can you say that all the 3 groups are equal so far as their abilities are concerned, so far as their range of values are concerned, range of scores are concerned? Okay, if I can say that, you see in the first group, in group A, lowest score is here 10, but in group B you see lowest score is 8, and group C again lowest score is 10. Group A highest score is here 30, group B highest score is 32, and group C highest score is 35. So here there is a variation. So that's why only measures of central tendency is not enough, because if you will compare the scores and the abilities of two groups, you can say that the mean score of the first group is 20 and the mean score of the second group is 20. But so far as individual scores are concerned, range are concerned, distribution of scores are concerned, abilities of the group is concerned, you cannot say that both the abilities of both the groups are same. Okay, so that's why only measuring the measures of central tendency is not enough. Rather, we should have an idea about measures of dispersion, or that is also called as measures of variability. It means you can now find out, you can now calculate the mean score, the deviation of mean score from the individual score. You see the individual score, like in group A, the last individual score is 30 and mean score is 20. So what is the deviation of this individual score from the mean score? Okay, and further, in this group also there is the variations of the scores, there is the variability of the scores. So that's why for measuring actual abilities of the students and to interpret the result of the students in different ways, only measures of central tendency is not enough. So that's why there is the concept of measures of dispersion or measures of variability. So here we will be calculating, we will be getting more you can say meaning about individual score, about the group score, and we can present it in different ways also. So that's why concept of difference, concept of dispersion is one of the very important aspects so far as interpretation of students' result is concerned. To understand more about the concept of dispersion, from the example that I have already cited, I can say that it is evident from the data that mean score of all the three groups are the same, but whether the groups are also the same, you can't say that the groups are same. Only taking the mean score, you cannot say that the groups are the same, because the distribution of scores in the groups are different. And further, it seems the mean score of three different groups are 20. We have already discussed that total number of scores were 8, and if you add all the individual scores, you will get 160 in all the times, in all the situations. So that's why mean will be 20 in three different groups. And further, we can calculate measures of dispersion when we see the group score individually, there exists a significant variation. So we are also getting that among the individual scores, a significant variation that is observed. Okay, and this variation is because of spreadness, or it is also called as dispersion. So how the scores have been spread and the dispersion of the scores. Okay, the position of the scores, you can say. Then measures of dispersion provides us more meaning of the distribution of the data. So only measures of central tendency is not enough. After understanding the very concept of measures of dispersion, then further let me to say that there are 4 different techniques, there are 4 different methods that you can use for measuring dispersion of the result or of the scores. That is range, quartile deviation, mean deviation. Mean deviation is also called as average deviation, and further standard deviation. So 4 calculations, 4 you can say techniques or methods that you can use for measuring dispersion. Now let us focus upon range. So here I will not take much of your time to discuss about range. Range may be defined as simple as that interval between the lowest and the highest score. Let there is a distribution. Okay, let there is a distribution of 40 students, and in that distribution, let one high score is there and the lowest score is there. Okay, so among the individual scores. So how you can calculate the range? It is the interval between the lowest and the highest score. So you have to, by your observation, you have to find out the highest score in that group, and you have to find out the lowest score of this group. And what you can do, you can calculate range by subtracting or by getting deviations or the difference or the gap between highest and the lowest score. Just like range is here, highest score minus lowest score. Okay. It is very common and general measures of spreads, and it's computed when you need to know a glance comparison of two or more groups for variability. So at a surface level, simply by observing the data, by watching the data, if you want to add certain meaning, simply you can say that what is the highest score of this group and what is the lowest score of this group and what is the range of it. So you can just subtract lowest score from highest score, you can get the range. Then further, it is all about a matter between two extreme scores. One is the highest score and other is the lowest score. So in this way, you can calculate range of the distribution. But range is not enough so far as analyzing and interpreting students' result is concerned. So that's why we have another technique that we can use that's called as quartile deviation. Okay. So now let us try to understand what is the concept of quartile deviation. So friends, you see the term that has been used here, this is quartile. Quartile means, the term quartile has been come from the word quarter. Quarter means 1/4. So this is the 1/4 deviation of the distribution of the scores in a group. Okay, so how can you do this? So quartile deviation is known as semi-interquartile range. This is called as a semi-interquartile range. Okay, so we'll try to understand that what is the semi-interquartile range. Quartile deviation is the 1/2 scale distance between the third and first quartile. So what you have to understand first, you have to understand that what is the first quartile and what is the third quartile and what is the second quartile. Third and first quartile. So that means third quartile is called as the Q3 and first quartile is called as Q1. So quartile deviation can be calculated by Q3 minus Q1 by 2. Okay. So this is 1/2 scale distance between third quartile and first quartile. Quartile deviation can also be defined as 1/2 scale distance between 75th and 25th percentile. So friends, here 75th percentile is equivalent to Q3, okay, quartile deviation, third quartile deviation. And P25 or 25th percentile is also equivalent to Q1, that is first quartile. So that's why we can say quartile deviation can also be defined as 1/2 scale distance between Q3 and Q1, or further you can say between P75 or 75th percentile and 25th percentile. And in symbol we can express quartile deviation as QD or in small q. So small q implies quartile deviation. This is the formula of quartile deviation, just like you say QD quartile deviation, or simply you can use capital Q, like Q is equal to Q3 minus Q1 by 2. So this is third quartile minus first quartile divided by 2. So this is the 1/2 of the scale distance between third and first quartile, scale distance between 75th and 25th percentile. Okay. So that's why what you have to do for getting quartile deviation, first you have to calculate Q3, then you have to calculate Q1, then you have to minus Q3 minus Q1, you have to do it, then you have to divide it by 2. So that will be the value of your quartile deviation. And as I have already said that Q3 is equivalent to P75 because this is the 75th percentile and P25 is the 25th percentile. So that's why Q3 is equivalent to P75 and Q1 is equal to P75. Here Q3 is called as P75 is a point of the distribution below which 75% and above which 25% of the cases lie. And Q1, that's called as P25, it is the 25th percentile. It means it is a point of the distribution below which 25% and above which 75% of the cases lie. So what you have to do, first after getting the score, you have to arrange the scores in descending order, okay, highest to lowest. And then after you have to find out the Q1, then Q3, then you have to subtract Q3 to Q1, then you have to divide it by 2. So that will be the quartile deviation. So friends, you see, I have already said that Q1 is the first quartile, that is equivalent to 25th percentile or P25. Q2, this is the second quartile, and we can define second quartile that Q2 is a point of the distribution below and above which 50% of the cases lie. Okay, so this is the Q2, this is the second quartile. So that is equivalent to P75. So P75 is equal to 50th percentile, or that is also equal to median. So now you might be, you remember that what you have studied in measures of central tendency. The definition of median is a point of the distribution below and above which 50% of the cases lie. The same concept and the same definition is applicable for Q2. At the same time, this is also applicable for P50, 50th percentile. And third quartile, that's called as Q3. So Q3 is a point, you can say, below which 75% of the cases lie and above which 25% of the cases lie. So that's why it's called as Q3 is 75th percentile. So you should compare quartile with percentile. So friends, now let us go forward to understand about how to calculate quartile deviation in ungrouped data. Here you see total 20 scores, individual scores are given 30, 22, 15, 18 accordingly. 20 individual scores are there. So here there is no repetition of the scores. And in the first step, what has been done here, you see scores in descending order. The scores are arranged in descending order. That means the highest score is 30, it will come at the first, and the lowest score is 4, it will come at the bottom. Okay. And further, as per the formula, what you have to do, you have to calculate Q3 and Q1. So Q3, I have already said that this is a point in the distribution below which 75% of the cases lie and above which 25% of the cases lie. Okay, so that's why here you see these scores are arranged in descending order. So total score is here 20. So in one quarter, what I can do, n by 4. N by 4 is equal to 5. Okay, and accordingly 3n by 4, just like to know the third quartile, that is 3n by 4, 3 into 20 by 60 by 4 is equal to 15. So that's why from the bottom you have to count 15 score. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here you see 15 score is 25 and 14 score is 22. So what you have to do, your third quartile point is in between this, because you cannot take 25 or you cannot take 22. If you take 25, then you see above which only 4 scores are there, which is not 25%. So that's why you have to find out the midpoint of 25 and 22. So that's why what I have done here, 25 plus 22, that is 47, divided by 2 is 23.5. Then again for Q1 is a point below which 25% of the cases lie and 25% of total n, 20 is here 5. So that's why now count 5 from the below, 1, 2, 3, 4, 5. So up to 9, you will find that total 5 scores are there. But how to calculate the midpoint? So it will be in between the 5th score and the 6th score. So that's why 10 plus 9 divided by 2. 19 divided by 2 is 9.5. So Q3 is 23.5 and Q1 is 9.5. Further, just put these values. Q3 is 23.5 minus Q1 is 9.5. So if I will subtract it, this is 17. So 17 by 2 is 8.5. So now quartile deviation is 8.5 in this ungrouped data. So friends, now let us try to understand how to calculate quartile deviation in a group data. Here you see in group data, scores are given in class interval orders, just like here you see 90 to 99, 80 to 89, 70 to 79. Accordingly, the scores are given in class intervals. Okay, the last class interval is 10 to 19. And frequencies are just like 2, 4, 5, 10, 35, 20, 13 accordingly. Total number of the cases is here 100. Okay, so this is a group data. You see the formula is the same. QD quartile deviation, or Q is equal to Q3 minus Q1 divided by 2. Okay. What you have to do, you have to calculate Q1. The formula of Q1 is L plus N by 4 minus cumulative frequency below the first quartile class. This is CFQB upon FQ. This is frequency of the first quartile class into class interval. Okay, this is size of the class. So N by 4 is 1/4 of the total number of the cases. L is lower limit of the quartile class. CFQB, I have already said that cumulative frequency below the first quartile class. FQ is frequency of the first quartile class, and CI is size of the class. This formula is just like median formula. Okay, and accordingly, the formula of Q3, that is L plus 3N by 4 minus CFBQ3 upon FQ3 into CI. 3N by 4 is 3/4 of the total number of the cases, and L is lower limit of the third quartile class. CFBQ, that is cumulative frequency below the third quartile class. FQ is frequency of the third quartile class, and CI is size of the class. Then here you see in the table how we have calculated it. Here the first two columns already we have discussed. This is class interval and the second is frequency. But the third column is here, you see the cumulative frequency. So how we have calculated the cumulative frequency? From the lowest class interval order, the frequency of the lowest class 10 to 19 is 3, and the cumulative frequency calculation of cumulative frequency will start from here. So cumulative frequency of 10 to 19 is 3. Then for 20 to 29, so here cumulatively the frequency will be added, just like 3 plus 8 is 13. Then for 30 to 39, 3 plus 8 plus 13 is 24. Then 24 plus 20 is 44. 44 plus 35 is 79. So accordingly, the frequencies will be cumulative, okay, and will increase cumulatively. And for the total number of cases is here 100, and cumulative frequency below the first quartile class is here 24, and cumulative frequency below the third quartile is here 44, because the first quartile class will be 44, because N by 4 is 25, total number of cases is 100, 100 by 4 is 25, so 25th case lies here. Below this 24th cases is there, 25th cases is in this class, that is 40 to 49. So this is the first quartile class. Then again 3N by 4, 3 into 100 by 4, that is 300 by 4, that is 75. Okay. So where is the 75th cases are there in this distribution? So here you see after 44, the next cumulative frequency is 79. It means your 75th cases are in this class interval. So this class interval is 50 to 59. So this you can say that this is the third quartile class. Okay. And third quartile cumulative frequency below the third quartile class is 44. It is below of 79. And frequency of third quartile class is 35. Frequency of first quartile class is 20. So friends, after knowing all such, what you have to do, you have to just find out the values of the first quartile. Just like the first quartile class is 40 to 49. So that's why lower limit of the first quartile class is 39.5. Cumulative frequency below the third quartile class is 24. Frequency of the first quartile class is 20, and size of the class is 10. So now you just put these values in the formula, and you will find that to simplify it, you will find the value that is 40. So you can say now Q1 of this distribution, the first quartile value of this distribution is 40. Then accordingly in third quartile, here you see in third quartile 3N by 4, here there is an error. This is not N by 4, this is 3N by 4. 3N by 4, that is 300 by 4 is equal to 75. So that's why 75th cases fall in the class that is 50 to 59. So that's why lower limit of that class is 49.5. Then cumulative frequency below the third quartile is 40, and cumulative frequency of third quartile class is 35, and size of the class is 10. So now you see only values have been incorporated in the formula, and calculation has been done, and now you can say that third quartile is 58.4. So friends, now you have with first quartile and third quartile. So what you have to do, as per the formula, this is Q3 minus Q1 by 2. Q3 is 58.4 and Q1 is 40. So 58.4 minus 40, that is 18.4 divided by 2 is equal to 9.2. So friends, quartile deviation or Q is 9.2 here, and you cannot do it simply by dividing it by 4. Rather, because the distributions of the scores are different. It depends upon the range, it depends upon the variations of the individual score. So that's why the interquartile range of the distribution is 9.2, of this group data is 9.2. So friends, for interpretation of quartile deviation or Q, we can say that quartile deviation is independent of the problem of extreme values, and therefore it is more representative and authentic than range. Okay. So here the extreme values, it is independent to extreme values when we calculate the quartile deviation. In extreme values will not affect the values of quartile deviation. So extreme value, I think you might be understanding that what is the let in a group 10 to 20 scores are there, but a single student has scored, let it's 82. So most of the students score are within 10 to 20 or 10 to 30, but one student score 85. So 85 is an extreme score. In another cases, let most of the students have secured 70 to 90, but one score has secured 15. So here 15 is also an extreme score. So what you can do, quartile deviation is independent of the problem of extreme scores. When there is an extreme score, that may affect the average value of a distribution, but that will not affect the quartile deviation. Okay, and we can say that Q3 minus median, if we subtract median from Q3 from the third quartile, the result that you will get, that is median minus Q1. So median, if you subtract median, Q1 from median, the values will be same. In case of non-symmetrical distribution, two possibilities may arise, just like Q3 minus median is greater than median minus Q1 if the scores are positively skewed, and on the contrary, if the scores are negatively skewed, we can say that Q3 minus median is less than equal to median minus Q1. Okay, so try to understand. And in a normal distribution, if the distribution is not skewed either at the positive side or at the negative side, you can calculate the normal distribution. So normal distribution, we can say that second quartile, that's called as Q2. Q2 is equal to median. Okay, so keep it in your mind. Many a time you will face such situation that in a normal distribution, Q2 is equivalent to what? So Q2 is equivalent the median score of the distribution. So friends, just to recapitulate, today we discuss measures of dispersion, or that's also called as measures of variability. We started our discussion by understanding the range and how we can calculate range, and further we discussed that what are the different techniques that you can use for measures of variability. We discussed about range, quartile deviation, and other two measures of dispersion, that is average deviation and secondary deviation, that we'll discuss in our further session. And while discussing the concept of quartile deviation, we have also discussed about the techniques and methods, the formulas that can be used for calculating quartile deviation, both in group data as well as in individual data. So, and also we have interpreted, this course interpreted the quartile deviation, that at which cases, at what situation we can use the concept of quartile deviation. So friends, for further queries, you can write to me. My mail ID is niradhar@ignou.ac.in. You can make me a telephone call. My intercom is 2994, and you can also visit my Facebook account, my YouTube channel. The name of my YouTube channel is Transforming Education, and my Twitter handle. You will find in my YouTube channel and Facebook Also in my Twitter, you will find many video lessons, more than 250 video lessons on different areas of knowledge, on different themes on education. That will really help you for your online course assessment for learning. At the same time, those videos will also help you for pursuing other courses. In our next session, we will discuss about the concept and calculation of average deviation and its interpretation. Thank you.